Hi, this is Dr. Eddie Morgan over at Clovis East High School. Welcome to Homework Help. We're going to be looking at the Math 1 homework for worksheet 4.4. Remember, each problem on this homework help mirrors a problem on your homework. So if you're having particular with just one or two problems, fast forward to those problems and take a look, and we should be able to help you get them started. Problem 1 asks us to translate the problem into a system of equations in two variables and then solve them. What we have is a business problem. It's a bicycle store, and it costs the bicycle store $2,500 each month to operate. That's the cost of renting the building, paying for utilities, light and that type of stuff, paying for water, paying for employees, all kinds of things that go into operating a business. The store also buys its bicycles $50 per bike from a manufacturer. It turns around then and marks them up and sells them for $150 to cover their costs. What they want to know is how many bikes do they have to sell each month to cover just the cost of operating. So let's start here. Let's assign our two variables. I'm going to let X equal the number of bicycles they sell. And I'm going to let Y equal the money that they earn, or the amount of money. It may not be earned or spent even. You just let it be money. Okay. So in the first case, let's look at our expenses. So our expenses Y are going to equal, first of all, it's $50 per bike, so it's going to be 50 times X. If I buy 100 bikes, I'm going to have to pay $5,000, and then plus the $2,500 each month for the rental and other things. Now, when it comes to my sales, my income, that's going to be $150 times each one. All right. So there is our problem. Now in this case, we could look at doing graphing. We could, but we're probably not going to. Be easier to get an exact answer the other way. Substitution and elimination. Well, I noticed right away that this is already solved for Y. Okay, so let's just take this and put it into Y. In other words, what we're doing is when do these things equal to begin with? So our break-even point is going to be whenever 150x equals 50x plus 2,500. Now we can solve that. Let's get all the x's on the left side by subtracting 50x from this side and this side. So we end up with 100x equals 2,500. Undo the multiply by 100 by dividing by 100. That goes away, and we have x equals 25. So the answer is 25 bikes is the break-even point. If they don't sell 25 bikes that month, they lose money. If they sell more than 25 bikes, then they're actually making money over their expenses. Problem 2 has to do with a hotel that's offering some weekend specials. In the first special, they get if you stay for 3 nights and 4 meals, it costs you $304. In Plan B, you stay for 4 nights, but you only eat there twice, $377. The question is, at that rate, considering that they're charging the same amount per night and same meals, what is the cost per night and cost per meal that they're charging in their special? So, first of all, let's assign our variables. Let's let N equal the cost of a night in the hotel, and let M equal cost of a meal. Okay. So when we look at Plan A, that's our first equation. Plan A, I'm going to stay 3 nights, so 3N plus 4 meals plus 4M equals $304. In Plan B, we stay 4 nights, so that's 4N plus 2 meals equals $377. All right. So now it looks like the best way to solve this is going to be elimination. It would take a little work to make a substitution. So let's take a look at what we could do. If we went with the first column here, we would end up with having to do a Papa Bear problem, multiply one by 4 and the other by 3. But I noticed the second one here, a little more probability here, because all I have to do is multiply this second equation by minus 2. That will give me minus 4m and cancel out. So let's do this. The first one we leave alone. 3n plus 4m equals 304. The second one, multiply everything by minus 2. So that's minus 8n minus 4m equals minus 2 times this is going to be 2 times 7 is 14, carry the 1, 14, 15, carry the 1, 6, 7, 54. And now we just add them together. 3 plus minus 8 is going to be negative 5n. This is eliminated as we wanted it to be. And then we have, this is going to be a negative 0, 5, 450. Okay? So now let's solve by undoing the multiply by negative 5 by dividing by negative 5. And we end up finding out that n equals, 5 goes into that, 90. So the cost for a night is $90. All right? So one night is $90. So now we need to find the cost of a meal. So we pick either one of these equations and plug back into it. So let's just take the first one. So I'm going to take 3 times the n, and we know what n is now. 3 times 90 plus 4 meals equals 304. So this is going to be 270 plus 4m equals 304. Subtract the 270 from both sides. And that goes away, and we have 4m equals 4 equals $34. So m, divide both sides by 4. So m is going to be 34 divided by 4, which ends up being 8.5. So we end up having that our meals cost $8.50 each. And that's our problem. Problem 3 has to do with the ballet. It says that 26 tickets were sold to the ballet. However, among those, you had children tickets that cost $5 each and adult tickets that cost $7. So there's 2 types of tickets. If the total amount of money was $160, how many children's tickets were sold? So first of all, let's define our variable. So I'm going to let C equal the number of children tickets. And I'm going to let A equal the number of adult tickets. You could use X and Y. It doesn't really matter what you call them as long as you remember what they are. So the first ticket we have is, what's the number of tickets that were sold? And we don't know how many of each, but we can write an equation. The equation is the number of children plus the number of adults added up to 26. Now the second one has to do with the money. How much money made? And they made $5 for every child ticket, so that would be 5 times C, and $7 for each adult, and that added up to 160. And now we have our 2 equations. Okay? So we could do 2 things here. We could do substitution. I could take this and say, okay, this is, so C equals 26 minus A, and put that in. That would be one approach. Or we could do elimination. Let's do elimination right now. What I'm going to do with elimination is I'm just going to multiply the top one by minus 5. Okay, so that's going to get us a minus 5C there. So when I do that on top, I get minus 5C minus 5A equals minus, and 5 times 6 is 30, carry the 3. 2 times 5 is 10, plus 3 is minus 130. And so then we write down the second equation, which we didn't change. This is eliminated. That's what we were trying to do. 7 minus 5 is 2A equals 30. So that means when we divide by 2 that the adult ticket costs, the number of tickets to the adults was 15. Right? So in that case, we know that the children equals 26 minus the adults. So 26 minus 15 means that the children tickets was 11. So they sold 11 children tickets. That's what they ask you. And they sold 15 adult tickets. And that's our answer there. By the way, if we had put this into here, if you're interested in what would have happened then, if we had taken this and put it in for C, you see we would have gotten 5 times C, we would have gotten 5 times 26 minus A plus 7A equals 160. If we distribute there, 5 times 26 is 30, carry the 3 to 130, plus 7A equals 160. Subtract 130. 7A equals, oh, we have to add the A's here, guys. Let me back up a little bit here, making a little error here. So we do have 130 minus 5A, but then we have the plus 7A equals 160. So if I subtract 130, and then I combine these two terms, 7 minus 5, I get the 2A equals 30, divide by 2, and A equals 15. So notice, if I did the substitution method here, I would get the same result as I did over here with the elimination. They both work the same. All right, let's move on to the next problem. Problem number 4 is an integer problem. It says that you have two numbers, and the sum is 13. They add up to 13. The difference, now remember, the sum means we're adding. The difference means we're subtracting. Okay? So the difference is 5. So let's define our numbers. First, let's let m equal one number, and n equal the second number. So first of all, let's look at the sum. We know that the sum of these two numbers, m plus n, equals 13. And then we have the difference. And the difference says that these two numbers, one minus the other, is equal to 5. Now we could look at doing a substitution, but right now I'm looking and I'm saying, look here, guys. Wow, we got ourselves a baby problem. If I just add these together, I get 2m. That goes away, and I have 2m equals 18, divide by 2, and I get that m equals 9. So one number equals 9, all right? So now we just go and find the other number. And so our second equation, well, our second equation said that, let's go to the first equation. So if 9 plus n equals 13, subtract 9, and you get that n equals 4. So what are the two numbers? The two numbers are 9 and 4. 9 and 4 add up to 13, but 9 minus 4 equals 5. Problem 5 is a coin problem, very popular on state tests, and notice here it's going to be on our tests as well. It says that Beth has 16 coins in her purse, but all of them are nickels or dimes. All right? And it says the total value is $1.25, and they want to know how many of each does she have. Well, first of all, let's define our variables. So I'm going to let n equal the number of nickels, and d equal the number of dimes. So the first equation we have is the number of coins. And in this case, the number of coins is, it means that n plus d adds up to 16. The second equation is going to be the value of the coins. I want to show you something that I typically do. We have the values of $1.25, and so you might be tempted to write this. You might be tempted to write, okay, every nickel is 0.05 N, and every dime is 0.10 D, and that adds up to 125. However, some of you don't like decimals, and so what you might do then is multiply the whole thing by 100, and then you would get 5n plus 10d, and watch this, 125. Now I do that immediately in my first one by just thinking, instead of in the dollar, I think cents. How many cents is a nickel? So a nickel is 5 cents, and a dime is 10 cents, and $1.25 is 125 cents. So notice I get the same thing I had up there. I just start that way. Okay. So first off, let's try elimination first. All right. So if I do elimination, I can start here and multiply everything by minus 5. Okay. So the top I get minus 5n minus 5d equals minus 5, and so we get 30 minus 80. And then our second one didn't change. 5n plus 10d equals 125. Add those together. Our nickels are eliminated. That's what we were looking for. 5d equals 45. Divide by 5. And you see that d equals 9. Well, if the number of dimes is 9, then the number of nickels is 16 minus 9, which is 7. So our answer is 9 dimes and 7 nickels. Okay. Now someone may say, well, I would prefer to do substitution. Okay, well, so let's do that. I could take this here, and I could say, okay, the number of nickels equals 16 minus the number of dimes. Just take this, subtract n from both sides, and now we're going to take this and substitute it in for nickels. So I come over here and write this equation. 5 times the nickels, but 5 times the nickels, and we discovered that the nickels are 16 minus d plus 10d equals 125. So when we distribute, we have 80 minus 5d plus 10d equals 125. So combine these terms together, and we have 80 plus 5d equals 125. Subtract 80. And we have 5d equals 45. Divide by 5. And once again, we end up with d equals 9, which then implies that nickels is 16 minus 9, or 7. So just noticing that whether you use substitution as we did here, or elimination as we did here, you're still going to get the same answer. And you just decide which you think is easier to do. Problem 6 is a classroom problem. It says that there are, in a number of classes, there are boys and girls, and they add up to 42. However, it says the number of girls is 2 more than 3 times the number of boys. So we have two equations here. Let's first set our variables. Let's let b equal the number of boys, and g equal the number of girls. Now the first thing we have is the total number. And it says that the boys plus the girls add up to 42. But then we have a relationship between them that says that 2 more, now 2 more means whatever it is plus 2. 3 times means 3 times the number of boys. So we end up saying the relationship is the girls equals 2 more than 3 times. So let's start with the 3 times. 3 times the boys plus 2 more. That's the part of this you got to get right. And now it's already set up for a substitution problem, so let's do it. If the girls equal that, then let's just do that and put it in there. So we can write our equation as b plus then 3b plus 2 equals 42. Now we'll combine terms here. 4b plus 2 equals 42. Subtract 2 from both sides, and we get 4b equals 40. Divide by 4, and we end up with b equals 10. So the number of boys is 10, and so the number of girls is going to be 42 minus 10, or 32. And just to check our answer, notice that if I take the boys and I multiply them by 3, so 3 times 10 plus 2 is 32, and that checks out. So our answer is boys 10, girls 32. Problem 7 is similar to problem 6 in that what we have here is we have Judy and Ann playing basketball, and they both score 29 points together. However, we have a relationship that says that Judy scores 5 points more than twice the number of points that Aaron did. So notice 5 more is going to be plus 5, and 2 times is going to be 2 times whatever she scores. So let's set up our variables first. I'm going to let J equal the number of points that Judy scores, and I'm going to let A equal the number of points that Ann scores. Now, first of all, we have the total points. So we know that J plus A adds up to 29 points. But then we have the relationship. And as we noted, we said that Judy equals 5 more than twice the number. So she's 2 times A plus 5. And then like we did in the last problem, since that's what J equals, let's just take that and substitute it in for J. So we're going to have 2A plus 5, that's J, plus A equals 29. So let's combine terms here. And we have 3A plus 5 equals 29. Subtract 5 from both sides. 3A equals 24. Divide by 3. And we have that A equals 8. So Ann scored 8 points. Well, that means then that Judy scored 29 minus A, or 8, which is going to be 21 points. Okay? So our answer is Judy, 21 points, and 8 points. And if we want to double check it out, let's take Judy is 2 times Ann, so that's 2 times 8 plus 5. So notice that's 16 plus 5, that's 21. So we know we got the correct answer there. Problem 8 is a vocabulary question. It asks us, what's the relationship between income and expenses before a break-even point is reached? And what's the relationship after? So let me just draw a little diagram to give you an idea what we're talking about here in income and expenses. Typically, at the beginning, your expenses are higher than your income. So your expenses start, even at 0, you have some kind of income here. So this is my income. This is my expenses. And then your income, if you don't sell anything, you're starting at 0. But as you sell more, it increases. So there's your income. So that's a very typical looking. And notice here's the break-even point where they both equal the same. But notice before the break-even point, in this area here, what's happening is before the expenses are greater than the income. Notice right here, my expenses here are bigger than my income here. Okay. However, after the break-even point, it reverses. At that point, the income is greater than expenses, and the company actually begins to make money. So at this point, then, my income, you see, is greater than my expenses here. So at break even, they're the same. You didn't lose any money, you didn't make any money. Before the break even point, you're losing money. After that, you're making money. Problem 9 asks this question. One brand of cranberry juice drink has 15% cranberry juice in it. Another has 40. You would like to put them together and make a drink that's 25. The question is, without calculating, which brand of juice will need more to make the drink you make? Explain. Well, I'm going to do a little calculating just to show you what's going on in my head. If I have 40% and I have 15%, and I were just to make even, I would add them up and make even amounts, divide them by 2, I would end up with 27.5%. So if you look at this, what I want, however, is 25%. So in other words, I want less. So as a result, my answer would be, I need to put more of the 15% and less of the 40%. So the answer is I need to put more of the 15% and then I do then the 40%. Another way to look at it is if you look on the line here between 25 and 40, 25 is closer to, to 15 and 40. 15 is closer to 25 than to 40. So I'm going to need more of the 15%, a little bit more, to get the exact amount that I need. All right. Hope that helped you. Have a good time with the rest of your work.